So thank you for coming. And today I'm Giovanni Faccioli from Deloitte. I'm from Italy. I'm leading the smart spaces offering in DCM, our region that comprises Italy, Greece, and Malta. And with my colleagues in Deloitte, we are developing several projects in the smart city area. And one of the most important partner of us is NVIDIA that allow us to build not smart city but intelligent city. And Adam, that is business development for NVIDIA and also managing the partnership with us, will tell us a lot of example of what we are doing and what NVIDIA is doing to help the city to be more and more intelligent with using real AI daily. So I
Thank
hand
you.
over to you.
Thank you so much. Thanks for having me. I appreciate it. Yeah, it's great to be here. I want to share with you, a lot of people are talking about solutions. I'm going to give you a peek inside the machine of NVIDIA a little bit, share with you a little bit of some AI work that we're doing that's really making a profound impact on a lot of different industries. It's great to work with Deloitte on this, and some of the work that we'll share is really groundbreaking. So about half of the world's $100 trillion GDP is in physical industries. And I think, as you know, a lot of people for the last 10 years, 12 years, AI has really been kind of stuck in the IT world. But with the movements of atoms as opposed to the movement or the movement of ions as opposed to the physical world. But there is incredible amount. Half of the world's GDP is really there's a lot of waste in physical industries, whether it's the movement of people, things, manufacturing, cities. And it represents a huge opportunity for us to work on. And so what I'm going to talk to you about, and with a lot of the work that we're doing with Giovanni and the team, is in this world, half of the world's GDP. And it's incredible. What we're doing is the concept of physical AI, which is underpinning a lot of the work that we're doing in smart cities, and a lot of which you see on the show floor, is AI that actually understands the physical world, that perceives, reasons, and acts like robotics does. And so it turns out that there's humanoid robots that NVIDIA is working on. There's autonomous vehicle work that NVIDIA is working on. Those are robots that move. But there's a lot of infrastructure in cities, manufacturing. These are robots that don't move, and we're going to turn them into robots. And physical AI is effectively the underpinning of that. With part of what makes physical AI work, and a lot of what you're seeing, the visuals are maybe a humanoid robot or an autonomous vehicle. In order to make physical, and in order to create automation of really anything, to turn a city intersection in Palermo, for example, into a robot, or an autonomous vehicle into a robot, you need to simulate in a digital twin to start with. There's a lot of simulation that happens. I'll give you an analogy. Any autonomous vehicle that you maybe have driven in or have seen has been driven billions of miles in a digital twin in a simulation before it actually gets onto the roadway. And of course, that makes sense. The AI needs to be refined and improved upon in a digital twin. And that makes a ton of sense. So imagine the amount of computation and simulation that happens in a digital twin. So there's really three computers. The first one is the simulation computer. The second one is the training computer. And in the early days when NVIDIA was talking about AI, we were doing a lot of training. Well, that's the second computer. So you train the model and you prove upon it. And then the third computer is the actual runtime computer where you run the agent, the robot. It's the computer within the robot. It's the computer within the autonomous vehicle. Or in smart cities, it could be the computer that's actually running in the intersection. And so there's three computers. And this concept of simulation, training, and deployment, simulation, training, deployment becomes this kind of circular loop. There's constant refining. A virtual loop. Yeah, a virtuous loop, exactly. And that's a lot of the work that we're doing. So I lead an effort within NVIDIA that focuses on a very particular robot. It's a very particular visual agent. And it's an agent that is actually visual. So our robots perceive, reason, and act based on cameras. We use cameras as our sensor. We use LiDAR and radar sometimes, but that's a lot of the work that we're doing with Deloitte right now is with cameras. It turns out that there is about 2 billion cameras deployed on Earth. It's the most widely deployed IoT sensor that we have. And it's really the underpinning of a lot of smart city efforts, whether it's traffic safety improvements, whether it's, there's an incredible amount of work. And Metropolis, the effort that I lead, spans a lot of different industries that you're seeing, manufacturing and supply chain and warehouses, all of which are robots. These are all facilities, infrastructure that we're going to turn into a robot based on cameras. Whether it's, safety, whether it's inspecting in a manufacturing facility or helping improve safety on roadways. And so it turns out that this is actually a very good example of physical AI because a lot of these agents are born in simulation and they're and then they're deployed in the real world. And what's really important is we're at a moment in time with AI and generative AI, which is incredible. I've been at doing this work within our team for 10 years, and 10 years ago it was very rudimentary. But with generative AI, we now have the ability to create true visual agents that you actually give a task to. These are little robots that are little agents, and whether it's you're an agent looking at city roadways. I want you to generate reports of what happened on the roadway for the last 24 hours and email it to me. Or you give them a task to watch out for unsafe situations and then, send me a note if something happens. This is the concept of an agent that you would think about for, ChatGPT. We now have agents for the physical world, and vision and a lot of the work that we're doing with Deloitte is part of this. And we're going to share a few examples of things that are actually being deployed right now. I'll give you just sort of a little visual to give you a sense of kind of what this looks like. The work that we're doing, really, a lot of it increasingly starts, these models, the visual models, are very sophisticated, and they often start their life in a simulation, in a digital twin. And so you can imagine that those three computers that I talked about, simulation, training, and deployment, requires an incredible ecosystem of partners, whether it's training partners, partners that create the data, partners that do the training, and partners that pull it all together into actual applications and solutions. That's right. Yeah, some of this work is with K2K, in Palermo. Yeah, and it's very interesting. I think you saw some examples of some of these visual agents being deployed in Palermo, and it's a very interesting case. It's a relatively small city, but it's incredibly important for the work that we're doing because it represents what a lot of these solutions will be deployed as, which is services, which is not just sort of video analytics, but this is actual safety services. That's right. To improve livability, and in some cases, actually offer revenue services for cities. It reduces costs, and in some cases, actually offers services that cities can turn into revenue, which is really interesting. I'm going to give you a couple more examples. This is some examples that might seem a little strange, but just to give you a flavor of the level of sophistication of these visual agents. These are all examples of deployments that we've had where we're giving these agents a task, watch a basketball game, and ask it a question. Tell me something about the roadway conditions, generate a report and send it to me. And you can imagine that this is, the labor shortage that we have in many different industries is a huge problem. These are augmentation helpers to help our operators with tasks that they have. And a lot of it is visual. This is an example of a standard operating procedure. Help me understand how I can, for workers that are doing tasks, watch the task and make sure they're doing the right things. And there's a productivity tool for any task that we have. You can imagine that's building a server, but you can imagine most tasks that we do manually have many steps, and these are agents that are helping this. And you can see in this example just how broad this is. This is manufacturing, supply chain, smart cities, smart healthcare, retail, smart spaces, exactly. And we collapse it into smart spaces because that's what we're turning this into with this work. So it's incredible. Yeah. Do you want to talk a little bit about sort of your perception of the work that we're doing with Palermo as an example?
So now, as Deloitte, we have seen a total shift on what we can deliver when we started working with NVIDIA. not only with NVIDIA hardware, but also with the NVIDIA stack of software that enable us to realize this kind of project that we have just seen, uh, enabling us to develop system that in real time can improve the situation that is happening, alerting the people for safety reason. And this is something that a few years ago was incredible. Now we are able to deliver. We have a center of excellence on NVIDIA that can help, of course, all our network, but mainly our customer, to realize in weeks what we can what they need.
Yeah, I think it's a good point because I think a lot of a lot of people see demos that I just showed and they think that it's just a demonstration and it's something that's in the lab. A lot of what we're showing is things that are being deployed worldwide. This is not in the lab and experiment. This is production. It's happening. It's going to be rolled out in cities, I think, in a big way because there's a huge need. And of all the physical industries that I talked about, I mean, cities are an incredibly rich area for us to go and tackle to reduce cost and offer services.
And what is the main message is that it's something that we can do sincerely in days, weeks, because there are platform that can enable us to build up the different situation or different use cases that our customer need. And what we have seen is not something that is so difficult to develop, something that we can deploy really fast.
Are there any questions? Do we have time for? Yes.
Players will play first data, vision, and AI.
Different. So essentially, in that area, there's two different trains of thinking. So you've got the Tesla sort of model, which is basically just using cameras and neural nets and AI, believing that sensors and LiDAR are not needed. But then you have on the other side Waymo, which believes you still need that for redundancy. Very different schools. And I'm curious, based on your sort of work, how you're seeing that play out, and if you're on one side of the argument or not, or what have you.
Yeah, it's a good question. I think that well, first off, I'll answer the question simply, and then I'll get. So we don't have an opinion on this. I mean, this is at the end of the day, this is it's very dependent on the solution. It's dependent on the philosophy of the developer. You gave an interesting example of autonomous vehicles, and in some cases you might want some redundancy. So you might want multimodal sensors, and that can make a lot of sense. It really depends. I think that the motion, interestingly enough, and I've been at NVIDIA long enough to appreciate the fact that people know this company now. For many, many years, I had to explain what this crazy company was doing, talking to people. And so what we have is we actually don't sell. We don't sell these things to people. We create platforms that people develop on. That is a fundamental of what we do. And so it's really the implementation of which kind of sensors you use is really up to you. But I will say, in a lot of the work that we do, vision and the sophistication of the models, and the fact that cameras, it turns out for cameras, particularly in city situations, cameras are so widely deployed. We have a lot of coverage. And so you might have multiple angles covering things. So a lot of cases, cameras only can work really well. That's a good point. Exactly. Yeah. Any other questions?
Thank you. You mentioned some use cases for cities and even the basketball game. I don't know if you've deployed it in customers from the private sector in their physical assets, and could you share some example?
Absolutely, yeah. There is an incredible amount of work that's happened in the private sector. our platform is, it's very funny within the company, within NVIDIA, our platform is, you kind of think of it as this horizontal platform that supports a lot of different verticals. Retail is a great example, right? Retail is a physical space. The nature of it is physical. There's customer journeys. There's loss prevention. So there's, that's one. Smart healthcare, smart hospitals. There's a lot of incredible work that can be done for patient safety. Again, when you look at the world from a physical lens, literally from a physical lens, you realize, wow, there is just an incredible amount of work that we can do to automate things. A lot of what we do, there's a lot of waste and a lot of risk that we can mitigate through this stuff. Manufacturing is its own very rich area. Manufacturing, you can almost think manufacturing is, the way I think about it is three ways. And all of these examples that I'm giving you is not hypothetical. We have customers, and most of the customers are even public that we have. But manufacturing is interesting because you can imagine there's the creation, the assembly of something. So you think about, you saw somebody making a server, for example, but you can think of it a Nike shoe, a server, a car. They're all kind of roughly made the same way. You can think of it, the camera, literally the camera zoomed in on a product very close and looking for defects. That's a classic computer vision problem that we're creating agents for. So visual defect detection. Now take that camera, zoom out a little bit, and watch me assemble something. And you can watch for my safety. You can create a co-pilot for me to be productive with a camera. Again, now that was like 1 square foot, and now we're talking about, I don't know, 10 feet by 10 feet. And then you can think about a facility level agent that looks at the entire facility and leverages all the hundreds of cameras within a manufacturing facility or a warehouse. And these are all examples of, multi-camera tracking and looking for pallets and watching for, forklifts. Soon as we unleash humanoids in the world, functional safety is going to be very important. We're going to want to know that everyone's safe. And so there's a ton of examples. Smart cities is another rich one. I mean, smart cities is its own wildly broad set of categories: traffic, public safety, pothole detection. I mean, the list goes on. So it's, yeah, but there's a ton in the private sector.
What's the upfront requirement for Metropolis? You can talk about Palermo. You can talk about any of the projects that you worked on. When the end user is trying to get a certain use case, is there a lot of data that they have to give you? What type of access do you need in order to start one of those projects?
Yeah. So some of the models are fine-tuned for a particular industry right out of the box. And so some of the applications, public safety is a good example. That one right out of the box kind of works. So these agents don't need a lot of fine-tuning. You can imagine on one end of the spectrum, there's that example, which is make sure that no one's slipping and falling, on a city street or something. That's on one end of the spectrum. Out of the box, that works pretty well. And you can imagine the creation of some wildly custom product where there's, no model has ever seen that corner of a factory before. You need some data. So it kind of depends. Fine tuning though is becoming a lot easier to do. And I should mention that a lot of the examples that you're seeing is, when I say generative AI is changing things for us in the vision space, these are vision language models. It's a VLM. You think of ChatGPT works on language, these models work on vision and physical world. They understand physical, if they watch a ball that rolls, I don't know, across your island in your kitchen, the model knows that the bottle hasn't vanished. It's just simply physically on the other side of the table. And that's a weird example, but that's actually profound. The model understands the physical world, right? So that's, anyway, but to get to your question, data sometimes is needed. And so that virtuous cycle that I showed with the 3 computers, that sometimes is part of the deployment. So we're starting to see cities, if we go back to the city example, I mean, a sovereign AI factory for a city would include those 3 racks of computers, probably. Training, creation of simulated data, training, and then deployment. So I'm kind of answering your question because it's so dependent, but there's a spectrum, and there's a lot of the applications, and many of them that you see on the show floor, literally out of the box, just work. It's not what? No, it has been a hurdle. The question was, has it been a hurdle to train these models? It has been a hurdle, but a lot of the tools and services from Deloitte are delightful, and it, part of that, the data flywheel is part of that package.
Thank you, presentation. I just want to know the platform that you just showed, the alarms or the alerts that's coming here on the screen. Is that part of your platform, or that's part of Deloitte Synergy platform, or that's another platform?
Yeah, the alerts that you're seeing are part of NVIDIA's blueprint, and so you can imagine that the alerts that you're seeing, they're you and I would look at them and say, wow, that's almost that looks like an application. But there's a significant amount of customization that can be done on top of that to turn that into an agent, a true co-pilot, if you will. So what you saw was literally out of our models, literally out of our tools. But that is not often sufficient to give to a customer, if that makes sense. So, there's RAG, if you're familiar with retrieval augmented generation, that RAG can be used on top of this. You can have other LLMs looking at this data. In some cases, we're mating speech recognition to this, and so now you've got visual data and speech data, and so you can imagine there's often a layer on top of what I'm showing that is a final product. So yeah, I think the answer is simply Deloitte will offer some customization on top of that to give you the very custom application that you're looking for. But that's very cool, but it's not sufficient a lot of the times. But I think the other point is that what you saw, I'm not even sure how to show this, but if I can go back, I can't go back, or maybe I go this way. Yeah, this one, right? This one. This is literally out of our tools. So the stuff that, we give it context. You're a basketball, I don't know, monitoring agent. Watch the game, watch the things. In this case, you're a traffic. So a lot of this stuff, you give it a prompt and you say, I'm giving you a task. This is the context. This is how I want you to talk to me, and I want you to generate a report with these headers, and go. And so the cool thing is that's the level of sophistication that we now have with this technology. It's wild. And for those of us who've got the scar tissue and the blood, sweat, and tears, and the arrows in our backs from this is completely wild. It wasn't that long ago that we were just putting bounding boxes around a cat or a dog with 80% accuracy and being super excited about that. This is transformational.
Transformation, because we can do in real time. So this is what we have seen in the past was similar things, but now we can process in milliseconds. Also, to advise the operators of the forklift, there is a critical situation with a response of milliseconds. So it's something that when we started talking about a small city, we never imagined that we can drive what is happening in real time.
Yeah. And I think it's also some of the stuff that you're seeing too is interesting, because you sort of joke when you talk to people. You say, hey, raise your hand if you're in the robotics industry, and no one raises their hand. And then after a discussion like this, people will raise their hand, because it turns out whatever, even in smart cities, we're going to be in the robotics industry, because a lot of this is automation. It's physical automation, and that's fundamentally robotics. And that's the transformation that we're coming through, which is pretty cool.
Any other question? No. Okay. Good. Thank you, Adam. Thank you.
Thank you so much.
To be with us, and thank you all to stay here.